I've hit record. Determine whether each expression is a polynomial. Determine whether each expression is a polynomial. So that'll be a yes or a no. Yes, it is a polynomial, or no, it is not. Then it says if it is a polynomial, so if you said yes, then you should be able to find the degree of the polynomial. And you could also determine whether it's a monomial, a binomial, or a trinomial. So let's write down number 1. That's a lot of information going on. We have 7ab plus 6b squared minus 2a cubed. 6ab plus 6b squared minus 2a cubed. So on your reading guide, you wrote down the definition for a polynomial. A polynomial is a monomial, or the sum of monomials, each called a term of a polynomial. All right, polynomials cannot have, anybody know what polynomials cannot have in them? A variable in the denominator. Y'all see any variables in the denominator in this problem? Y'all see any variables down in the denominator?
No, ma'am.
Nope. Okay. We also cannot have any exponents that are negative. So do you see any exponents that are negative here? No, we can't have any variables in the denominator, and we cannot have any exponents that are negative. So we can say yes. Yes, this is a polynomial. Okay, as long as there are no variables in the denominator and no negative exponents, this is considered a polynomial. And the reason we have to define that is because we have all these rules where we're going to add polynomials and subtract polynomials and multiply polynomials. And if this is not a polynomial, then that rule would not apply to it. Okay? So that's a good thing. We don't want variables to be in the denominator, and we don't want negative exponents. Okay, so it is a polynomial. The next thing says, if it is a polynomial, determine its degree. So you have to look at each term. So the first term is 7ab. What's the exponent on the a? A 1. What's the exponent on the b? A 1. If your term has 2 or more variables, you have to add the exponents to determine the degree of the term. So 1 plus 1 is 2. So the first term has a degree of 2. Has nothing to do with a 7. The degree of the term only has to do with the exponents. All right, the next term is 6b squared. Only one variable in 6b squared, so you just take the exponent on the only one variable, and that exponent is 2. Go to the last term. It only has one variable, so you take the exponent on that variable, and the exponent on that variable is 3. Now tell me again why the degree of 7ab is 2.
Because there's also one variable.
When you have more than one variable, you add up the exponents on those variables, and that tells you the degree of the term. Okay? Now, which degree is the highest? 3. So 3 would be the degree of your polynomial. You take the highest degree term, and that's the degree of your entire polynomial. So if your degree was 2, 2, and 5, then the degree of your polynomial would be 5. Okay, if your degrees were 2, 1, and 2, then 2 would be the highest, and 2 would be the degree of the polynomial. It's the highest degree term. Now, if this has one term, we call it a monomial. If it has 2 terms, we call it a binomial. If it has 3 terms, we call it a trinomial. It has 3 terms, so this one has a special name, and it's called a trinomial. All right, I did that one slow with you, so the rest of these ought to go pretty fast. Number 2, 2y minus 5 plus 3y squared. 2y minus 5 plus 3y squared. Determine whether this expression is a polynomial, yes or no. Yes, it is. There are no variables in the denominator, and there are no exponents that are negative. Okay, then it says, if it is a polynomial, and it is, because we said yes, determine the degree of the polynomial. So we got to look at the exponents here. The first term has one variable, and that variable's exponent is 1. So the degree of the first term is 1. Okay, the degree of the last term is 2. Now, here's a question. What's the degree of negative 5? It's 0. Why is that degree 0? It has no variable. If a term has no variable, then its degree is always 0. Okay? So which degree is the highest? 2. So then 2 would be the degree of your whole entire polynomial. The highest degree wins out, and that would be the degree of your whole polynomial. Is this a monomial, a binomial, or a trinomial? This one's a trinomial because there are 3 terms. Alright, number 3. I'll squeeze it in up here. 3x squared. 3x squared. Is this a polynomial? Does it have any variables in the denominator? Does it have any exponents that are negative?
No.
Then this is a polynomial. Okay, it can have one term, guys. Okay, poly actually means one or more. Okay, so all you're doing is you're checking to see if there's any variables in the denominator, you're checking to see if there's any negative exponents. So it is a polynomial. So what is its degree? 2. Okay, we don't have to go find the degree of all the terms. There's only one term. So whatever the degree is, which will be whatever the exponent is 2. So that's the degree of your polynomial. And then is this a monomial, a binomial, or a trinomial? It's a monomial because mono means one. Monomial. I'm not a very good speller. Monomial. Monomial means 1. Bi means 2. Tri means 3. Number 4. 4m divided by 3p. 4m divided by 3p. Is this a polynomial?
Yes.
No. There's a variable in the denominator. Can't have any variables in the denominator. So when it says, if it is, what's the degree? Well, it's not. So it doesn't have a degree. Alright, so the only thing that you can do with number 4 is just say no. Because if it's not a polynomial, you can't find the degree of the polynomial. And you can't tell me whether the polynomial is a monomial, a binomial, or a trinomial. So you end with the no there. No, because there's a variable in the denominator. Alright, questions about number 4? Alright, number 5. I'm going to turn my page. Number 5. 5m squared p cubed plus 6. 5m to the second, p to the third, plus 6. Is this a polynomial?
Yes.
Yes, it is. So what is its degree? 5. Is this a monomial, a binomial, or a trinomial?
It's a binomial.
It's a binomial because it has 2 terms. Okay? That plus or that minus sign is going to separate your terms. So 5m squared m to the third, that's one term, and then the plus 6 is the second term. Everybody know where the 5 is coming from?
Yes.
Where's the 5 coming from?
The base.
2 plus the base. Oh. 2 plus 3 is 5. It's not coming from this number right there. That's just a coincidence. Okay? If a term has more than one variable, you have to add its exponents to find the degree. What's the degree of the 6?
1.
0. My goodness gracious. You don't ever consult your brain before you speak sometimes. I know you know the right answer. It just comes out. It just comes out. It's like a waterfall. It just comes out. Okay? Alright, last one in this set of directions. Number 6. Number 6. Love and friendship, guys. Love and friendship. 5q to the negative 4 plus 6q. 5q to the negative 4 plus 6q. Is this a polynomial?
No.
No, why not? Has a negative exponent, which really means that q is supposed to go in the denominator. Same thing, right? Negative exponent really means that variable's in the denominator. That's why you can't have either one of those. So the end on that one. Can't answer anything else. Questions about the first set of directions? You're going to be working some of those for homework tonight. Okay? Next set of directions say, write each polynomial in standard form. Identify the leading coefficient. All right, number 7. So, hey guys, they're already telling you, hey, you have a polynomial, write it in standard form. Okay, so we don't have to determine in this next set of problems whether we have a polynomial or not. We already do. Okay, and standard form is when it's organized by the exponents, and you always start with which exponent? The biggest. So standard form would be 2x to the 5th would come first, and then the term that has the next highest exponent would be the positive 3x, and then the term that has the lowest exponent would be the minus 12, because it doesn't have a variable, so its degree is 0. So standard form is from the highest degree term, or the highest exponent, all the way to the smallest. Okay? Then it's asking you for the leading coefficient, and we're going to abbreviate that LC. Okay? Anybody know what the leading coefficient is? It's 2. Okay? The leading coefficient is always the number in front of the term with the highest degree. So if you put your problem in standard form, then that 2 will always lead the problem. It'll be the leading coefficient. Okay? That's going to be really important to us later on when we graph and when we factor. We'll be talking about the leading coefficient, and y'all will have to know what that is. All right, questions about number 7. All right, number 8, same set of directions. Negative 4d to the 4th plus 1 minus d squared. Negative 4d to the 4th plus 1 minus d squared. It's already a polynomial. Nobody's questioning that. They want it to be in standard form. So what term has to come first? Which term has the highest exponent?
Oh, negative 4.
Negative 4d to the 4th comes first, and then the next highest exponent term would be minus
D2.
minus d2, and then finally plus 1. That's standard form. Highest exponent to lowest exponent, and then the leading coefficient would be
Negative 4.
-4. It's the number being multiplied times the variable that has the highest exponent, which should be in the front if you have it in standard form correctly. All right, number 9, 4z minus 2z squared minus 5z to the 4th. 4z minus 2z squared minus 5z to the 4th. The first term, if it's in standard form, needs to be what?
Oh,
Negative 5z to the 4th. And then the next term needs to be negative 2d to the 2nd. And technically that 4z is positive because there's no sign out to the left. So you would have to write plus 4z. And then the leading coefficient would be negative 5. We're going to do one more of these, and we're going to swap, and we're going to start adding and subtracting polynomials. Questions about 7, 8, or 9? All right, same set of directions. Last one in this set of directions, number 10. 2a plus 4a to the 3rd minus 5a squared minus 1. 2a plus 4a to the 3rd minus 5a squared minus 1. Put this polynomial in standard form. 4a to the 3rd negative 5a squared plus 2a minus 1. Good job. And the leading coefficient would be
4.
4. All right, pretty easy, right? Y'all can do this. Okay. Next set of directions are going to say find each sum or difference. So that means we're going to be adding or we're going to be subtracting. Okay, we're going to practice 4 of these and then y'all can start on your homework. All right, so for number 11, the directions change. Okay, and the directions say find the sum, which means that you're either adding in the problem, or find the difference, which means you're subtracting. Find sum or difference. Number 11. parentheses, 6x to the third minus 4, close parentheses, plus parentheses, negative 2x to the third plus 9. So I know that you have heard the phrase combine like terms before, correct? And that's what you're going to do. As long as you're adding, you're going to identify which terms are like terms, and you're going to combine those, and then you're going to always write your answer in standard form. So if we're always going to write our answer in standard form, let's combine the two terms that have the highest exponent first. So that would be 6x squared and negative 2x squared. So what's a 6 and a negative 2 combined to be? A 4. So we're going to get 4x cubed. And then our only other two like terms are negative 4 and positive 9. And they combine to be a positive 5. So they're not asking for the degree here. They're not asking for the leading coefficient. They're just asking you to add the two polynomials. So this would really be a binomial plus a binomial. So we're really just combining like terms. Not that difficult. You're combining like terms. Highest degree first, so your answer will be in standard form. Alright, adding is actually a little bit easier than subtracting, but it always has been. Adding's always been easier than subtracting. So let's look at number 12. It's a subtraction problem. So we have a giant polynomial here. It has 4 terms. There's not a special name for a polynomial that has 4 terms. We just call it a polynomial. We have the monomial, the binomial, and the trinomial, but if it has more than 3 terms, we just say, oh, it's just a polynomial. All right, so we almost do exactly the same thing, but we're not adding here, okay? So you have to really tell yourself, hey, self, we are not adding, we are subtracting. When you're subtracting, everything in the second set of parentheses, it's like there's a pretend or an imaginary negative 1 that you've got to multiply times everything in the parentheses that you're subtracting, okay? Nothing happens to what's in the first set of parentheses. Nothing happens at all, okay? But in the second set of parentheses, everything in the second set of parentheses will get its sign changed because you're subtracting it. So if we drop the first set of parentheses, nothing's ever going to change in the first set. But in the set of parentheses that you're subtracting, it's like you're multiplying an imaginary negative 1 times all those terms. And your g squared's not going to be positive anymore, it's going to be negative. And your positive 2g is not going to be positive anymore, it's going to be negative. That's because you are subtracting. And when you subtract something, you are changing its sign. That's what subtraction does. Okay? Once you realize all the signs are going to change in the parentheses that you're subtracting, now you're going to hunt down and combine like terms. Which term has the highest degree? G to the third. Is there any other G to the third? Nope. So you just bring it down. Then our next highest degree would be 2. And I see 2 terms that have a g squared in them. So what's a negative 2g squared and a negative 1g squared combined to be? A negative 2 and a negative 1. What's negative 2 and negative 1 combined to be? Not multiply. No. Yeah, if they're both negative, you add them and you keep their sign. You add them and you keep their sign. Alright, so that's negative 3g squared. My next terms that I'm going to combine are my g's. 5g minus 2g is... 5 minus 2 is 3. Positive 3g. Y'all are scaring me for a minute. You're not answering. And then the last term that we have is the plus 6. And it just has to come down because it's all by its little lonesome self and it doesn't have a like term to combine. Alright, now that looks pretty complicated. Questions about number 12? Subtraction is always harder than adding. It always has been. There's nothing new about that. Alright, number 13. We're subtracting again. So in 13, we've got 4 plus 2a squared minus 2a in the first set of parentheses minus parentheses 3a squared minus 8a plus 7. So anytime we're subtracting, all of the signs in the parentheses that you're subtracting have to change signs. That first parentheses, nothing changes there, so we just drop the parentheses and we write everything down. Okay, and then some of you will just know what to do. That positive 3a squared is going to become negative 3a squared. The negative 8a, when you subtract negative 8a, that's going to become a plus 8a. And that positive 7, when you subtract a positive 7, it's going to change it to a negative 7. You can think subtract, you can think distribute by negative 1. It all means the same thing. But all of the signs, all of these signs, if it's being subtracted, you have to change all of those signs. And then you go back and combine like terms. So which degree is the highest? The 2's. All right, these two terms have a squareds in them. What do they combine to be? Negative 1a squared, or the book is just going to write negative a squared. And then you got some a terms. They're going to combine to be plus 6a. And then finally you've got the positive 4 and the negative 7. Negative 3. Now let's just say you're doing your homework and you got a problem like 13. You don't necessarily have to write the original problem. Are y'all with me? As soon as you realize you're subtracting, you could start on this second line of work. Does that make sense to anybody? You could start on that second line and you wouldn't have to rewrite that twice. You would just need to know that the first parentheses doesn't change, but because I'm subtracting, all the signs in the second parentheses have to change. So you could cut that down to just 2 lines of work there. What I have in the yellow box and then the final answer. If you want to write the original problem, I'll leave that up to you. All right, now I'm going to go backwards to the problem that we just did. Number 11. Y'all look at number 11. Did we change signs in number 11? We didn't change any signs at all. We just combined like terms. That's because we weren't subtracting, we were adding. And adding doesn't change any signs. It's that subtraction that changes the signs. So the last one that we're going to do is another addition one. And additions are always going to be easier because you don't have to change signs when you're doing addition problems. So we have 8y minus 4y squared plus 3y minus 9y squared. So because we're adding, you can just underline your like terms. So negative 4y squared and negative 9y squared is negative 13y squared, and positive 8y and positive 3y combine to be a positive 11y. So you can just outright combine like terms as long as you're adding. If you're subtracting, you got to change all the signs in the parentheses that you're subtracting. All right, any questions? All right, you have a homework assignment. You've got about 20 minutes left in the block. Your homework is page 468. And you're working on 21 through 43 odd. These go with your notes. Do what?
Notebook.
Notebook quiz. You're so smart.